Today's June 18th and I'm going to do another LeetCode daily challenge. So let's start. Okay, today's problem is 2294. Partition arrays such that maximum difference is k. You are given an integer array nums and an integer k. You may partition nums into one or more subsequences such that each element in nums appears in exactly one of the subsequences. Okay. Each element only appears exactly once. Cannot reuse elements. And that's something that like I did yesterday where I was initially going to reuse a lot of stuff, but this time they're very explicit. Return the minimum number of subsequences needed such that the difference between the maximum and minimum values of each subsequence is at most k. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order. Ooh. A subsequence is a sequence that can be derived from another sequence by deleting some or no elements without changing the order. Interesting, because when I was reading this problem, I thought, oh, why don't I just do like what we did yesterday and sort the array? But we cannot sort the array this time. We can't sort the array because they want to preserve the subsequence. So instead, let's run through an example because I'm a little bit confused on how to do this problem. 36125 with a k of 2. We can partition nums into the two subsequences 3, 1, 2, and 6, 5. The difference between the maximum and minimum value in the second subsequence is 6 minus 5. Let's go to 1. The first one is 3 minus 1, which is 2. Since two subsequences were created, we return 2. It can be shown that 2 is the minimum number of subsequence needed. Okay, so now that we can't use sorting, I'm reading something interesting. We want the minimum number of subsequences, and we don't know what that number is. So one technique that might be useful is it's like hidden in this, but it might be a binary search approach where how would it go? It would be like this minimum number of subsequences needed. Let's just call that number of subsequences. It would be like, do you need 1? Do you need 2? Do you need 3 subsequences? Do you need 4? Do you need 5? So on and so forth. And what this would do is you would run binary search starting from like the left and the right pointer or whatever, left and right potential value, in order to find the first, right? Because they want the minimum number of subsequences, where if we were to run this into like a function, it would output true, right? So let's just say 1 was false, 2 was true, 3 true, 4, everything past this would be true. I think that's how it would work. And then our goal is to find the very first true and return it. So we would return 2. Huh. But now that I think about it, why can't we just sort? Like the order doesn't really matter, right? Because they still want the minimum if that subsequence minus the maximum, or the maximum minus the minimum. Uh, this might be tricky because even though it says subsequent, our result has nothing to do with these actual subsequences. Like this might as well have been 1, 2, 3, 5, 6. I don't think it matters that. I think we could actually sort this. So let me maybe come back to this like binary search idea. It might have threw me off. Instead, let me try. Let me try just sorting this. So it'd be 1, 2, 5, 1, 2, 3, 5, 6. 1, 2, 3, 5, 6. And then we just want to see how far we can last, I guess. How far can we go with one subsequence? Yeah, subsequence doesn't matter. They're just trying to throw us off. So this one would be 2 minus 1. It gives us 1. And k would be 2, so we can move on. That's totally fine. 3 minus 1 is 2. Is it less than or equal to? At most k. Yeah. So 3 minus 1 is 2, so we can move on. 5 minus 1 wouldn't work, so we would have to start a brand new one here and then do this. Yeah. Okay. Okay, we'll just sort it. For I in range n, and then make sure that we say n is the length of nums. I guess we kind of want a left and right pointer. So we want a couple of variables, I guess. We want left, right. Left is 0. This is almost a sliding window type problem. And then right is your I. And then you also want to keep track of the number of num partitions. I might be off by 1, but I think we always start with a 1. Like there's going to be 1 partition, I think. So for nums in right, if nums at right minus nums at left is greater than or equal to is greater than k, then this is bad. We need a number of partitions to go up. We need to set our left to be right and then just continue. I think that's fine. What happens if it's less than, like, if we were here and this works, what should happen? We should just move on to the next thing. And then if that worked, we should just move on to the next thing. So I think if it works, we don't touch anything. It's as soon as it doesn't work where we have to up the partitions. Like we're going to move down to this partition now. So this is like partition 1, and then this is partition 2. And then now when we go to the second partition, we need to make sure that our left is updated to current, and then we'll move the right over. Okay, I think that's how it works. Then we just return the number of partitions. Okay, let me submit that. Interesting problem. Interesting. Usually, like sometimes I like do a problem and it's like a medium, and I'm like, oh, that should be easy. But I think lately these problems are quite they're quite involved. And the reason why I say this is because like after reading it, they try to throw you off by using this like subsequence term where you think, okay, now I can't sort it, right? It needs, and that's literally what I was thinking, like I can't sort it. And then I was thinking, oh, maybe we need some sort of binary search approach. But then it's the same idea, like sorting it or not. We still only care about like we only care we really want them to be very close together, and like subsequences we can delete any elements that aren't close together, so might as well just sort it, right? That's like free for us. So sorting it, kind of adding kind of like a sliding window type problem where you have like keep track of a left and right pointer, and then you're always saying, okay, there's always going to be one partition, right? Like we always start with one partition. Worst, best case scenario or whatever, like that one partition will last us the whole way. But we might run into a situation where this partition breaks, and that's this if condition. If that condition is true, then then we need a new partition. And so then we create the new partition by setting the left pointer to whatever right is currently on, and then we just keep going. So, yeah, it's like the code's nothing hard, but I think getting the result might be a little tricky. Okay, anyways, um, let's do time and space. This is O of n. Space, oh, huh, that's interesting. I just realized yesterday I said it was linear, right? But the hardest thing about this is O of n log n in order to sort the nums array. So there's your time right there. Space is just O of 1 space. So time is big O of n log n, and space is constant space. Okay, cool. Hope you guys enjoyed this video, and thanks for watching.